Welcome to the fourth season of the Energy Central Power Perspectives podcast. This is the show that brings leading minds from the energy industry into the podcast booth to discuss the challenges and trends that are transforming and modernizing our energy system. And a quick thank you to Prescient Transmission Systems, our sponsor of today's show. Now, let's talk energy. I'm Jason Price, Energy Central podcast host and director with West Monroe, coming to you from New York City. And as always, I'm joined by Matt Chester, Energy Central podcast producer and community manager, dialed in from Orlando, Florida. So, Matt, transmission systems are key to expanding the renewable market and meet the increasing demand for a clean energy future. The federal government and many of the ISOs and RTOs are putting big bucks to expand transmission. We've had executives discuss transmission development. So Matt, give us a skinny or a recap on what has been covered in the past episodes.
Yeah, you're right about that, Jason. We've seen a swell of focus in the podcast on how to clear up the transmission backlog, open up the grid to be able to meet growing power demands, rising calls for clean energy, and increasingly available digital tools for the grid. And that focus on the podcast definitely reflects the priorities of the wider energy and utility landscape that has recognized the bottleneck and how grid solutions are clean energy solutions. So to your question, in terms of previous episodes our listeners may want to tune into to catch up, I encourage them all to go to our Energy Central SoundCloud page, where you'll find a playlist we have titled The Grid, Reliability, and Resilience, a playlist that I'll link in the show notes so you can also find it there. But when you look at that playlist, you'll see episodes like Mark Gabriel, the CEO of United Power, discussing how transformation on the grid will unlock new opportunities for some smaller utilities. You'll see Charles Marshall and Brian Drum of ITC discuss tangible ways to improve the state of our transmission infrastructure. You can find Gene Rodriguez with the Department of Energy's Office of Electricity cover how the federal government is approaching grid planning and much more. So we're excited to add today's conversation to this list and to keep digging into the why and the how of focusing on modernizing transmission systems.
That's great. And those are great suggestions, great podcasts that we've run. So thanks for bringing those to our attention again. So Matt, to dive deeper into the discussion, we are delighted to welcome to the episode today Tony Sleva, a distinguished professional with over 45 years of experience in the field of power systems. Currently serving as the president of Prescient Transmission Systems, Tony has showcased his expertise in power system design and analysis throughout his career. Tony is a seasoned engineering manager, electrical engineer, project manager, and a thought leader in next-generation power system concepts. His contributions extend beyond leadership, encompassing roles as a continuing education instructor, training program developer, forensic investigator, author, and research engineer. At Prescient Transmission Systems, Tony spearheads the development of innovative services and technologies, focusing on areas such as wildfire risk assessment, power outage prevention, and broader advancements in power system engineering. With a wealth of knowledge and a commitment to advancing power systems, allow me to welcome Tony Sleva to the Energy Central Power Perspectives podcast.
Thank you for inviting me to participate in today's podcast. As I approach my golden years, my focus is encouraging and nurturing development of the next generation electric grid. With today's technology, there's so much to discover, so many opportunities for improvement, and so much more to do. When I ask, what can I do to encourage innovation? My answer is to give packets of good ideas to engineers and ask them to plant the seeds and grow these ideas into harvestable actions. Hopefully, this podcast will inspire the innovators in our industry.
Well, we're thrilled to have you here, so thank you for that. And Tony, to kickstart the conversation, let's start with a basic question. What is it that you think the utility sector needs to do to modernize?
During my lifetime, I have witnessed phenomenal changes in communications, in manufacturings, and in almost everything that I touch. We are living in a rapidly changing world. Electric utilities need to embrace changes that will be needed to address climate change. This includes electrification of energy consumption, integration of renewable energy, wildfire risk reduction preparedness, increased electric vehicle utilization, and so much more. Electric utilities can look to other industries for inspiration on how to modernize. Automobile manufacturers maximize the safety of their products by conducting crash tests. Nuclear power plants maximize production by developing plans for both planned and emergency activities. These are examples of things that utilities need to copy.
Okay, perfect. So share with our audience who may not be familiar with your company, what role does Prescient Transmission Systems play in planning in that future?
Prescient provides consulting services for electric utilities in a wide variety of areas. This includes wildfire risk reduction, renewable energy integration, electric vehicle integration, system modeling, energy balancing, and physical security. Our focus is what can be improved by using today's data collection technology more effectively. As subject matter experts, our staff has assessed equipment failures for electric utilities, energy producers, insurers, and large industrial customers. We are passionate about sharing our vision of the next generation electric energy grid. We see change as an opportunity as we prepare for a future with climate change. System modeling is one area in which Prescient excels. With the electrification of energy consumption, regional transmission operators need to upgrade their models in order to anticipate future challenges. We provide guidance on improved system modeling for a future with millions of distributed energy sources and millions of electric vehicles. One of our strengths is understanding residential and industrial energy utilization. This includes understanding the impact of three-phase faults on the stability of the energy grid, understanding the risk of a wide area blackout if a particular substation is sabotaged, and understanding the likelihood of a transmission or distribution line sparking a wildfire given meteorological conditions and protective relay settings. We use our models to craft prudent, cost-effective changes that clients can implement to reduce risk.
Okay, so on that note, with all these advancements going on in the grid, and the uncertain adoption rates that these technologies present to utilities, solar, storage, EV, and so on, what advice do you have for the utilities as they try to forecast what they'll need to deliver in the future?
Well, electric utilities need to accept that uncertainty is part of their future, and they can't let that uncertainty hold them back. They have to act as leaders in the transition to increased renewables, increased energy storage, and increased electric vehicle adoption. Plus, they have to start looking at how these different things work together so that we wind up with the best possible outcome. Electric utilities, they have the opportunity to envision and create new systems and new paradigms. When they embrace change and they embrace new technologies, they should encourage their employees to innovate and share their ideas. For example, distribution lines are built today to transmit power from substations to customers. When customers put rooftop solar on their houses, we want to be able to transmit power from customers back to the substation. And so these are changes that you have to make to the distribution system. Plus, they have to come up with models to deal with the realities of climate change and future risks to the grid. Widespread electrical vehicle integration is going to require energy balancing. It's going to require new models for fault-induced delayed voltage recovery. Sometime a long time ago, like 20, 25 years ago, we started worrying about fault-induced delayed voltage recovery in California. And the reason was that we have so much air conditioning in California. This is the type of thing that we're going to have to worry about across the whole United States as we get more and more air conditioning. Plus, fault-induced delayed voltage recovery should be the criteria for physical security of our substations. And we should be doing stage fault tests, which are the equivalent of crash tests, to see that our models are correct and our understanding of the system is correct. There's a lot we can do. We should do assessments of the design and operating practices and change the operation of our power systems as the meteorological conditions change. If there's 7 days without rain, we should be changing our protective relay settings so that the settings become more sensitive as we've gone days without rain. And improving physical security is a real big thing we got to do. There's rogue individuals that could create havoc by damaging substation components. And Prescient has an awareness of all these items, and we're willing to offer consulting services to utilities across the United States.
That's interesting. Let's talk about physical security a bit more. Are you seeing, I mean, there have been some events in the past couple of years, but are you seeing the trend increasing in this area? And are we more vulnerable in this area? Just, can you talk a little bit more about that?
Yes, but before I answer the question, I have to share with you that I've designed and installed security systems at nuclear power plants. And the reason for mentioning that is the nuclear power regulations are much more stringent than what the electric utility grid is accustomed to. This means that my understanding of security is different than the focus of utility engineers. My focus is on motives, knowledge, and skills of saboteur before I start determining the vulnerability of the system. Based on my analysis of utility facilities and the breadth of information that is available on the internet, I believe that utility facilities are more vulnerable in 2024 than any time in the past. The number of threats is increasing across all industries, and the electric power industry is no exception. Just think in December of 2022, we had the Moore County shooting of a substation that left 40,000 customers without power. In 2020, we had the explosion outside an AT&T communication system that disabled 911 and internet services. And everyone knows about the incident at the Metcalf substation in 2013. Traditional physical security is created by honest engineers who don't necessarily think like saboteurs. My thoughts are that vulnerability is going to continue increasing until we prepare for saboteurs with industry knowledge. And they can get this industry knowledge either through extensive internet research or insider knowledge. The media, the news industry, is also increasing the vulnerability of the electric utility grid. On Christmas Eve, I was sitting at my computer and I saw the news media describe an incident at a substation in Pennsylvania. And the helicopter flew over the substation, so I was sure to get a good view of the substation and the roads leading into the substation. All these things make the grid more vulnerable.
Yeah, that's a good point. And certainly water utilities have been hit through cyber attacks over the past few months. So it's an ever constant challenge for our industry.
It's also disturbing to me that a single intruder can get into any open air substation, a 500 kV substation, a 345 kV substation, or 230 kV substation, and they can create a multi-state blackout using nothing more than a bolt cutter. You don't need explosives and you don't need weapons to black out power in Washington, D.C., New York City, Dallas, Miami, any major city. If an intruder gets in the substation, we have the risk that we can black out an entire state or metropolitan area.
So, Tony, talk to us about best practices and how you bring this to the utilities and grid operators. What do you typically see as them getting right, and what are they getting wrong? Just help us understand how you operate and work with the utilities in this.
I see the nuclear power industry as having a lot of really good practices that have to be addressed by the electric utility industry. For instance, nuclear power plants use limiting conditions of operation. The limiting conditions of operation tell me that I have 24 hours, 3 days, 7 days, some amount of time to either repair or replace components. This means they're really focused on quick repairs. The electric utility industry, we typically take our time replacing transformers. And when I tell utility executives they should be able to replace a big transformer in 3 days, it's met with consternation. That's the best way to describe it. Other things that I see in the nuclear industry, like in a nuclear power plant, you have physical separation of redundant systems so that if someone takes out system A, system B is still functional. This means that you don't put redundant cables in the same conduit, you don't put them in the same cable tray, and you have two control rooms. So things like this are really important to start implementing and start using in the electric power industry. When I think about the crash testing for the National Highway Traffic Safety Administration, they require crash tests of all new vehicles. In the electric utility industry, that says that we should be doing stage fault tests. I haven't seen a stage fault test in about 20 years. So there's really good practices that we should be copying from other industries.
Yeah, that's interesting. Let's move on from security because we talked about it, the lead-in around transmission, your transmission work, and of course, transmissions in your company name. So talk to us about the kind of transmission consulting that you do, that you provide. I think that you feel that there's ways to optimize the existing transmission lines. Can you share a little bit about that and how do you measure that going forward?
Sure. Transmission lines, they've remained essentially unchanged since the 1950s. We've made some changes to put in conductors that allow more amps per phase or lower losses per mile. And we've put series capacitors in a few transmission lines, but we haven't really changed the design of transmission lines for a long, long time. So I'm thinking the first thing we have to do is we have to put microprocessor controlled solenoid type series reactors in series with circuit breakers and substations. And the reason for doing this is when a fault occurs, if three-phase fault occurs, the voltage collapses across a wide area from between 80 to 160 milliseconds, depending upon how quickly the relays respond. Well, 160 milliseconds is 3 revolutions of a 1200 RPM motor. And the 1200 RPM motors that I'm concerned with are air conditioners. So if the air conditioners stall and the fault is cleared, I now have to try to reaccelerate a whole bunch of air conditioners at the same time. Inrush current on air conditioning motors, on all motors, is much greater than running current. So on a peak load day, you could try to start thousands of air conditioners simultaneously, or you're really reaccelerating thousands of air conditioners simultaneously. If you put solenoid type series reactors in series with the circuit breakers, these series reactors will actuate, they'll change the impedance of the system, and they'll allow voltage to recover in about 16 milliseconds. So I can have voltage recover before the fault is cleared and before any air conditioners stall. And this is really going to change the dynamics of the power grid. So we should be looking at technology to allow us to ride through faults. And then one of the concepts I mentioned before, fault-induced delayed voltage, that isn't an issue if I can recover voltage in 16 milliseconds. Another change is that we should start changing transmission line design so that we can control the impedance of the line. Right now, the impedance is just a function of the conductors you put up and the length of the line and the spacing of the line. If I can adjust the impedance of the line, I can match the flow over the line to the demand on the system. So I can put series capacitors in my lines to reduce the impedance, to allow more flow, or I could put inductors in the line to increase the impedance and back off the flow. And I should be routinely putting these in all my transmission lines today. So I'm thinking there are a lot of opportunities to change the design of transmission lines and really improve and enhance the operation of the power grid. And doing these things will allow us to get 15 to 20% more capacity out of our existing power grid without building another single transmission line.
That's interesting because all this comes down to modeling, right? You run these models, you run these pilots, and you play it out. So I recall in our planning session, Tony, you did question the viability and I guess the standard practice as we approach at utilities, as we approach building out modeling. So I think you have some opinions around the practice of the modeling process and you think it could be improved. So can you talk about what is right, what is wrong, and what do we need to do about modernizing and optimizing our system as it relates to building out models?
Yes. I've used models to do short circuit calculations, to do load flow studies, and to do transient stability studies. After I did all that modeling, I started working in nuclear power plants. And what I had to do is use different models in nuclear power plants to simulate the response of a nuclear power plant to the design-based accident that the plant was designed for. And it turns out that the nuclear models are much more involved and much more detailed than the transmission system models are. So what we should do is we should upgrade our transmission system models to the same level of detail that I see in nuclear plant models. In nuclear plant models, I'm looking at motor starting, and in transmission systems, I'm looking at motor reacceleration. And both of them are telling me that I have a different model under the starting and the acceleration mode than I have under the normal operating mode. One of the concerns I have is that most of the models that I look at were developed in the 1950s when we were using mainframe computers. Today, what we've done is we've taken the models and converted them from a mainframe computer where they took hours to complete to a laptop computer that can give me an answer in 3 seconds. So I'm concerned that in 2024, on a peak load day, 50% of connected loads are going to be air conditioners. And if the voltage drops below 70%, everywhere the voltage drops below 70%, the air conditioners are going to stall. And we have to start modeling that. And we have to make sure that we understand what risks we have on the system. And the system is changing. If I look back when I was doing calculations in 2000, I was focused on large steam turbine generators at nuclear power plants and coal-fired power plants. Today, I've got a lot of wind turbine generators out there on land, and now we're starting to put them in the ocean. So we have to make sure our models are right and they represent what we're doing. Regional transmission and operators, they have to start hiring shift technical advisors and using the shift technical advisors to staff their control centers. These shift technical advisors are the guys who are going to be using the models, and they're going to be evaluating equipment failures, near misses, pending outages, recommending improvements to the design and operation of our systems. So there's a lot we can do. There's an opportunity. I think a young engineer who's starting the industry today should have exciting work for the next 25 years.
Yeah, I would imagine so. My takeaway from everything you're talking about is that basically running the energy industry, running the utilities, running transmission is not business as usual. It's an entirely new paradigm that the industry is playing in, and we need to be thinking differently and question everything that we're doing. So, Tony, much appreciate all this insight. And we're going to give you the last word to our audience, but at this point, we want to pivot to what we call the lightning round, which gives us an opportunity to learn a little bit more about you, the person, rather than you, the professional. So I have 5 or 6 questions to ask. I ask you to keep your response to one word or phrase. So, Tony, are you ready?
Yes.
All right. What's your favorite way to spend a day off?
Hiking. I've hiked the Camino Santiago in Spain, the Appalachian Trail, the Pacific Crest Trail. So I enjoy hiking.
Oh, very nice. What's a hidden talent or unexpected hobby you can share with us?
I volunteer as a conductor on the Oregon Coast Scenic Railway and also as a Gandhi dancer. So I drive railroad spikes every opportunity I get.
What historical figure would you invite to your dinner party?
Oh, this is a tough one. I'd like to invite Nikola Tesla one night and Charles Fortescue the next night. And I would want every member of my staff to be there to make sure that we got every question we could possibly want to ask them. And I want my dinner party to start at lunchtime and go right through the night.
If you didn't take a career in the world of energy, what else do you think you may have ended up doing?
This is an easy answer. I've shared this with many people. I'd be a coal miner. When I was ready to graduate from high school, my high school math teacher, Phoebe Tomko, asked me where I was going to college, and I said I was going to become a coal miner. Phoebe took action, talked to my parents, pulled some strings, and got me enrolled at Penn State University. And here I am today.
Very nice. That was an excellent job. And we have, and I want to bring to the attention of our listeners that we have something called SpeakPipe, which is new for 2024. And it gives you, the audience, an opportunity to ask a question. We will sift through them and we can ask future guests a question that you may have and hear your voice on the podcast. So look for that to come in future episodes. And I said, Tony, I'll give you the final word. So since you did a great job in the lightning round, and I have imagined you have some closing thoughts to share with our decision makers and listeners from the utility industry. So the floor is yours.
Grid modernization and preparedness for climate change are achievable goals. Utilities need to make a conscious effort to embrace change, prepare their models and their facilities, and lead the transition to next generation electric energy grid. Prescient Transmission System is here to help. I want to note that during my 50-year professional career, I've had the opportunity to be mentored by some of the brightest minds in the electric utility industry. At this time, I'm working hard to pass the baton to the next generation of electric utility engineers, managers, and executives. My request is that everyone who listens to this podcast can take a few minutes and ask themselves, who can I help become the next Nikola Tesla, the next Charles Fortescue, or the next Phoebe Tomko?
Thank you for that. That was a terrific closing. Much appreciate the time today, learning from you and hearing really more questions than answers. So I think that's always a thoughtful piece and a nice reception to today's discussion. And you can always reach Tony through the Energy Central platform where he welcomes your questions and comments. So for now, thank you again for joining us on the show, Tony.
Thank you. It's fun. I hope everyone who listens to the podcast takes my advice and becomes a supporter of the innovators in their workplace.
And we also want to give a thanks to the podcast sponsor that made today's episode possible, to Prescient Transmission Systems. Prescient works with the electric utilities to integrate next-generation concepts into grid design and operating practices. Prescient's team provides insights on wildfire risk reduction, electric vehicle integration, energy balancing, system modeling, and physical security. Contact Prescient Transmission Systems today for a free consultation through their Energy Central profile or online at www.prescientelectric.com. That's www.prescientelectric.com. And join Tony for his upcoming webinar discussing effective physical security for substations, happening Tuesday, February 20th, 2024. Register now through the Energy Central calendar or on its website, prescientelectric.com/webinars. And once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com. And we'll see you next time at Energy Central Power Perspectives Podcast.